All right, let's get right into it. We walk over them every single day. But seriously, right beneath our feet is this whole world of incredible silent engineering. We're talking about plant roots, and not just as these passive straws for water, but as actual active architects that are shaping the world from below.
I want you to think about this for a second. When you pull a carrot, it comes out with this single, really satisfying pop. But a patch of grass, oh man, you are fighting this dense, tangled mat of earth. It's a completely different ballgame, and that's not by accident. There is a brilliant reason for it.
So the answer to that little puzzle? It all comes down to the fact that plants don't just grow roots randomly. No, they follow one of two fundamental architectural blueprints, two master plans for conquering the underground world.
So here's the key idea for this whole explainer. You have to think of every plant as its own engineer, designing its own foundation. And it's always working from one of two master plans. Let's call them the deep anchor and the wide net. Okay, let's start with our first blueprint, which is perfectly described as the anchor. This is the taproot system, and believe me, its entire strategy is about growing deep and growing strong.
The origin story here is absolutely crucial. A taproot system starts its life from this tiny part of the plant embryo called the radicle. This one point grows into a single, dominant primary root that just plunges straight down, and then you have smaller, secondary roots branching off the sides. It's that classic root you probably drew in science class as a kid.
But, this blueprint comes in a couple of different models. First, you've got your standard model. These are your typical taproots like what you'd find in dandelions or even young pine trees. They do the basic job of anchoring and absorbing water. And then you have the upgraded model, the storage taproot. And this is that upgraded model in action. These roots aren't just anchors. They're basically underground pantries, just swollen with starches and sugars. It's a super clever survival strategy, It allows the plant to store up enough energy to get through a cold winter and then flower in its second year. And that brings us right back to our first question. Pulling a carrot is so simple because you're literally just yanking up one big central storage unit.
All right, now for our second blueprint. And if the taproot is a deep anchor, this next system is its polar opposite. Think of it like a wide, sprawling net. We're talking about adventitious roots.
The key difference is right there in the definition. See, unlike taproots, which always grow from that embryonic root, adventitious roots can pop up from almost anywhere else. The stem, the leaves, you name it. They're totally independent of that primary root, which creates a completely different structure. You see this all the time in monocots.
So, the most common version of this net system is what we call the fibrous root system. Instead of one main root, you get this dense cluster of tons of roots that are all about the same size. This creates that super tough soil-gripping mat we find in grasses, wheat, and barley. And that finally solves our mystery. This is why a patch of grass is so ridiculously hard to pull up.
Okay, let's put them side by side to really lock this in. So, to recap, taproots start from the embryo's radicle. Adventitious roots, they grow from the stem or leaves. Structurally, taproots have one main anchor, while adventitious systems form that fibrous mat. And this is the core difference between dicots, like our carrots, and monocots, like grasses. Just two completely different strategies for survival. But here is where it gets even cooler. That adventitious blueprint is unbelievably versatile. It's not just about making fibrous nets. Plants have customized this system to create some truly amazing tools.
We're definitely moving beyond the basics now. These are roots that have evolved to do some pretty extraordinary things, to act like stilts, to literally climb walls, and even to create their own unique versions of those storage pantries. Let's just do a quick run through this gallery of ingenuity. First, you've got prop roots, like in maize, which grow from the lower stem to act like little stilts, giving a tall plant extra support. Then there are climbing roots, which you see on ivy, that develop from the stem to grip onto surfaces and climb up towards the light. Tuberous roots, like a sweet potato, are the adventitious system's answer to storage. It's not a taproot, but it stores food just as well. And finally, you have aerial roots, which grow entirely above ground, like in plants such as orchids or anthurium.
So let's bring this all home. Once you understand these two blueprints and all their custom modifications, it gives you a completely new way to see the plant world around you.
So here's your final takeaway, a little cheat sheet for these underground architects. Just remember the taproot system, modified for storage in something like a carrot, And then the super versatile adventitious system, which gives us everything from the soil anchoring nets of wheat to the supportive prop roots of maize, the climbing roots of ivy, and even the storage pantries of sweet potatoes. Each one is a perfect solution to a very specific engineering problem. It is just amazing to think that all of this complex architecture is happening completely out of sight. It really makes you wonder, if plants have mastered this level of engineering below the ground, what other hidden, brilliant designs are we walking past every single day?